All right, so I'm not very musically talented. That's why I work in IT, right? In this lesson, we'll be talking about relational databases. Why are they cool? Because the data can have relationships with each other. All right, so in the previous lesson, we talked about programming, and we talked about concepts such as variables and a little bit of different data structures. But imagine that you have an application that needs to span more than one computer, or an application that needs to store a lot of different information, or an application that needs to store a lot of different information that's accessible from a lot of different places. How do you manage that kind of stuff, right? This is where relational databases come in. Relational databases are super cool because it allows us to maintain a lot of data in the same place and then use creative queries to extract that data. So let's go through and create a sample database table, which is essentially a collection of different data elements. So we're going to have our rows here, and we're going to have some columns. This is going to be a human resources database that's going to hold data on every single employee for our little makeup company. So in the first column, we're going to have an ID, and this is going to be 1, 2, 3, 4, 5, and 6. In the second column, we're going to have first name, but we're not going to call it first name because computers and databases don't really like spaces. So we're just going to call it F name. In the third column, we're going to have the last name as L name. We're going to have date of hire. And then in the last column, we're going to have salary. All right, so this is a sample data structure. You can say a schema, right? That's the technical term for it. Now, let's talk about a few important elements about this table. First of all, every table should, it doesn't have to have it, but any application that you see, it will have it. It will have an ID column. An ID column is important for data retrieval and performance reasons. Every single row in the database table should have a unique number assigned to it. And this number is called the primary key. The primary key has to be unique per table number. So in the cases of our employee database, we have a pretty random set ID that's just incremented by 1. However, in most places, that will use something like an employee number. Because no two employees can share the same employee number, that will suffice as the primary key. Next, we have different data elements here. First name and last name. These are going to be characters. They're going to be, in programming language, they're strings, but in database, you have several other data types. This was SQL Server, for example, there'll be NV chars. Those can store string data. Now, why is it important in the database to specify the type of data that we have? Well, because when the database tables are written, certain space will be allocated for each row in the table, right, and each data element. So it'll behoove you, if you're designing database tables, to devise your schema so that it takes up the least amount of space and it still provides adequate functionality. But we'll talk about that a little bit more down the road. So now we have our date of hire column. This will be a date field. Now, a date field is a whole different beast inside of SQL programming in general. There's like a million ways to document date. I mean, you're talking about, it could be a string, it could be like the name of a month, followed by the day, followed by year, could be day, month, year, could be in different time zones, could be UTC, GMT, it could be the number of seconds from January 1, 1970. And if you think I'm lying, look up epoch time. Look up Julian dates. Anyway, dates are a huge pain in the ass, and I hate dealing with them, but it's a fact of life that you do have to deal with them. So anyway, the date field gives you some additional functionality with that data. But it needs to be put into the database in a specific format that it will accept. For example, you can run a query later on different date ranges. So for example, give me something that's between these two dates or not within these two dates. And finally, we have salary, which will be, let's say, an integer field. Integer field lets us perform numeric calculations. So for example, by default, if you have an NV field and it stores 1, you will not be able to add that 1 to anything else because it is a character field and that's stored as a string. However, you can do the math with an integer field by default without doing any kind of conversion. So now this table gets populated with data, and then you can run different queries on it. For example, give me all the employees whose salary is below $25,000 a year. Or give me every single employee where the date of hire is after blah blah date. Or give me all employees whose last name starts with V. The queries that you can run are pretty much up to your imagination. You can pull out this data, you can slice and dice it any way you'd like. So now, let's take this example and let's get really cool with it. Let's say that we have another HR table, and let's call this table incidents. So this is where the data goes if you do something bad and get reported to HR. Not that I haven't had any problems with my HR department. Anyway, we're going to have the same kind of table structure, rows and columns. The first row will be ID. Then you'll have incident date, reported by. You have employee ID, and then you'll have notes. Now, we're not going to go through all these different columns. I just want to illustrate one critical point about databases, and that is different joins. And what that allows you to do is it allows you to take data from one table and join it to the data in another table. In our employee ID field, you will have something called a foreign key, and that is a value that must match a value in a different table. So let's say that we have a couple employees here, and they're all troublemakers. 2, 3, 2, 3, 4, and 2. So this employee 2, giving us a lot of grief. Basically, with relational databases, what you can do is you can run one single SQL statement that will give you results from both of these tables. It will look up the value of 2 here and the value of 2 here, and the value of 3 here and the value of 3 here, and it will aggregate all this data into one single result set. This is very cool stuff, and as you will see in our next lesson, which will be a programming demonstration, this is actually not as hard as you might think it is. Anyway, as far as careers go, database administrators usually go pretty, the good ones are in demand because they can significantly optimize the way almost any single application runs. And especially if you have a large enterprise with multiple databases, that could really equate to some cost savings for many organizations. Additionally, DBAs usually do not require knowledge of anything else except databases, right? So you don't need to know networking, they don't need to know Active Directory. They need to know a little bit about security, but that's usually controlled by somebody else. So if you're new to the IT field and you kind of like this kind of stuff, you might want to look into becoming a DBA and obtaining a certification by one of the main database vendors, such as Oracle or Microsoft for SQL Server. Anyway, I hope this makes it a little bit more clear. And if you like my Rumble, if you have any questions or if you have any concerns or I didn't say something right, shoot me a note. I'll be more than happy to explain it some more or create some more videos. Thanks.